I want to show the return on investment page that we have. So what is this? Let's start with the example here. Data set is where you're trying to predict propensity to buy. So a bunch of sales leads that you have and information about them, and you have information if you were able to close the deal and make the sale or not. And now with Opel, you have built a model that, given the information about that lead, can predict if that lead is going to close or not. Now, once you have that, in order to actually impact your business, you need to make certain business decisions based on the output of that model. Otherwise, there's no point in having a model. So, what is the business decision? Perhaps it is, are you going to try to follow up with that lead and invest time from your salespeople into trying to close that deal? If that's the case, you need to decide what's the threshold that you as a company would use. Meaning, if the model predicts that that sales lead is going to close, with what percent probability are you going to act on it? You can just choose the standard 50%, but that might not be the optimal solution. Let's take a look at how this works. Let's say you know that the cost of pursuing a lead is $100 right here. And you can put whatever you want. Maybe the time of your salesperson, costs you $150. Once the lead closes, what's the benefit of having that lead? In this case, this is just a name that was used in the data set of the class of the target that you're trying to predict. But this is the equivalent of closing a sales in this example. So let's say if you do close the sales, on average it's $1,000. It's the benefit to your company of closing sales. What's the population size? So how many sales leads do you have? Maybe you just acquired a new list. Let's say you have 500 sales leads. And what's your budget? This is, no matter what and how beneficial, you cannot spend more than X many dollars because you might only have a certain number of salespeople. And so there's only so many leads that they can go after. But for now, let's just say this is a really big budget. In this case, let's say 100,000, so that it's out of the graph here and it's not something that we're looking at right now. What you see on this graph on the right is the profit that you make, which is calculated by getting a look at the population above a certain threshold and calculating, okay, that means everybody above that threshold is going to cost you $150. And then for that population, which ones of them are going to close, and then multiplying that by $1,000, which is the benefit. And then you calculate the profit that you are going to have. So you can here manually adjust that threshold and see what it means. So you can be very precise and say you're going to only consider deals that have a greater than 90% probability of closing, right? So you're going to go after very few deals. So your cost is going to be very small, but also you're going to leave a lot of money on the table because you're not going to go after a lot of the deals that would close. So if you hit optimize, we actually calculate the optimal threshold to use. So let's take a look at what this means. This means that anybody that the model says has a higher than 14% probability, you should go after. Now, what's going to happen if you do that? Calculated profit of $77,550. It also gives you a little bit more information so you understand. It says that if you do this, if you follow this along, you are going to go after about little less than half of your population, 44% of your population. So of all the sales leads, you're going to tell your salespeople to go after 44% of them. In this case, 223 leads out of the population of 500 leads. Let's take a look at the second page that we have. We want to show you the information about making this decision, not just the profit, but also what happens to your sales leads. Precision is, of all the sales leads that you're deciding to go after, what percentage of them are actually going to close? So 50%. So half of everything you tell your salespeople to go after will actually close. Coverage is, of all the leads that you have in your list that would have closed had you gone after it, how many of those are you capturing? In this case, it's 93%. So of all your 500 leads, we're telling you to go after 223 of them and ignore the rest. And of all the leads that would have closed, you're just missing out on 7%. So very, very little that you're leaving, money that you're leaving on the table. You're basically saving your sales efforts from going after the 55% of all your leads, which is very efficient, obviously. Here we actually show you the graph of that threshold and the trade-off, right? So the blue line represents all the sales leads that would close, and the purple one, the sales leads that wouldn't close. So you can imagine placing a threshold right here where the mouse is. That means everybody here in the blue you would catch, and you would only capture a few of the sales leads you would not close on the purple. So obviously, if you could perfectly separate purple and blue, that's the ideal scenario, where every lead you go after closes, and all the leads you ignore wouldn't have closed anyway. That's what we show you on the third page. We show you what the ideal situation is if you had the perfect model in the fuchsia, and if you had no model at all in blue, and then our model here in the middle in purple. So what you see on the x-axis is the total population, all your leads. What you see on the y-axis is all your leads that would have closed. If you have no model at all, and you go after 50% of your population, you will get 50% of your total leads that would have closed, because you're basically choosing them randomly. You're just randomly picking 50% of your leads to go after. If you have a perfect model, you know exactly which leads would close, which means you can go after all the leads that would close and achieve 100% of them, and ignore all the leads that wouldn't close. In this data set, 24% of all the leads would have closed. If you just randomly go after leads, it's only 1 in 4 roughly that would close. And here you see the model, and you see the line here of where the threshold is that we chose. That's the optimal point, right? As you can see, it's still very advantageous. You're achieving almost perfect 100% of all the leads you would have closed. And you're sparing your salespeople from going after more than half of your leads that they would have unnecessarily spent their time on. I know there's a lot of information on this page, but hopefully the more you play with it, the more you'll see how powerful it is to help you actually make business decisions that are valuable once you have a model that has been built.